Here we are going to learn the method to examine the consistency or inconsistency of a non-homogeneous equation. We have this: A represents the coefficient matrix, X the variable matrix, and B the matrix of constants. We have done this. Now, if the constant matrix, the matrix of constants, is equal to the null matrix, then Ax is equal to P is called the homogeneous system of linear equations. This we will do next time in the next video and assignment. In this we are going to do this one. If B is not equal to the null matrix, then Ax is equal to B is called non-homogeneous system of linear equations. So we have this. First we have to calculate determinant of A. We are going to have two options. Either it is not equal to 0 or it is equal to 0. This we did in the previous video and assignment, unique solution. In this video assignment we will do this. If you get determinant of A is equal to 0, then we have to calculate adjoint of A into B. Again, two options we are going to have. If adjoint of A into B is not equal to the null matrix, no solution and the equations are inconsistent. And if it is equal to the null matrix, then again two options we have. Maybe inconsistent, maybe consistent, having infinitely many solutions. We'll discuss this in detail. So here, this is the non-homogeneous linear equations in two variables. Now in 11th standard you have studied that if A1 by A2 is not equal to B1 by B2, this is the condition when two lines they intersect, that is we have a unique solution. If A1 by A2 is equal to B1 by B2 is not equal to C1 by C2, here the two lines are parallel to each other but they do not intersect. Here we say no solution. Now this is called inconsistent. And here it is consistent. And the third case is when A1 by A2 is equal to B1 by B2 is equal to C1 by C2. This is a condition when the two lines, it's a coincident line. That is infinitely many solutions. Now, the same thing we are going to prove by matrix method. That is, we take A as the coefficient matrix. We have done this. We take X as a variable matrix and is constant metric. Now this is not equal to the null matrix, so it is non-homogeneous. So this is the equation, we have done it before, and X is equal to A inverse B. Now this A inverse, for this A inverse to be unique, first what we do, the first step is to calculate the determinant of A, and if it is not equal to 0, that means the solution is unique, consistent, and we have solved many questions. This is the condition. Here is equal to 0. Then we have two conditions. Then we go to calculate adjoint of A into B, because we calculate this A inverse B, x is equal to A inverse B. Now this is equal to 1 by determinant of A into adjoint of A into B. So this we calculate, and if this is not equal to 0, now this is the condition, no solution, it is inconsistent. It has no solution. And this is the case when adjoint of A is also equal to 0, this is also equal to 0, then we have two conditions here. It can be either this infinitely many solution or no solution. Many solution or no solution, or inconsistent. In this case it is consistent. So this is what we are going to deal with in this video. So here, just by looking at the expression, I told you if A1 by A2 is equal to B1 by B2 is equal to C1 by C2. I think this condition is satisfied here. It is 1 by 3 is equal to 1 by 3 is equal to 3 by 9. So the answer will be infinite solution, infinitely many solutions, because the lines are coincident. Now, matrix way we are going to solve this way. 1 and 3, this is 1 and 3. The coefficient matrix, the variable matrix is this, and the constant matrix is 3 and 9. So first step is to calculate the determinant of A. It is 3 minus 3, which is equal to 0. Then we calculate adjoint of A. The principal diagonal elements interchanged here will remain same. So adjoint of A into B will be equal to 3 minus 3 minus 1 1 into 3 and 9. This is 9. So 9 minus 9, this is 0. Minus 9 plus 9 is 0. So it is a null matrix. Therefore, determinant of A is 0. Null matrix 0, sorry, and adjoint of A into B is also null matrix. Therefore, it is infinitely many solutions. And it is consistent also. Now in this equation, you'll find that A1 by A2 is equal to B1 by B2 but not equal to C1 by C2. 1 by 3 is equal to 1 by 3 is not equal to 3 by 4. That means the lines are parallel to each other. They do not meet at any point. So answer should be no solution. But in matrix method, we prove this way. This is the coefficient matrix, the variable matrix, and this is the constant matrix. So first we find determinant of A, and that is equal to 0. Then we have to find adjoint of A. It is 3 and 1. You know that interchange and they get sign changes. The next step is to find adjoint of A into B. That is 3 minus 1 minus 3 1. 3 and 4. 9 minus 4. 5 and minus 9 plus 1. Minus 5. Now, adjoint of A into B is not a null matrix. Therefore, inconsistent. It has no solution. One example, 3 variables, and it's a non-homogeneous equation because the constant matrix is not a null matrix. Coefficient matrix, the variable matrix. First we need to calculate determinant of A, which is equal to 0. Since it is equal to 0, we calculate adjoint of A also. Then we multiply adjoint of A into B and we get a null matrix. Since we get a null matrix, the system of equation is either consistent with infinitely many solutions or is inconsistent. How to do this, I'll explain you in the next video and assignment. The 3 questions are there, and I have to find lambda if the equations have unique solution. So the coefficient matrix, the variable matrix, and the constant matrix, for the condition to be unique, determinant of A should not be equal to 0. So determinant of A is minus 1 plus lambda. Minus 1 plus lambda should not be equal to 0, so lambda should not be equal to 1, since equations have a unique solution. This is one of the example.